So the warm-up, 98. That one, once again, take it home and do that with your family. All right. Just a reminder, tentative date for Saturday Academy is March 7th. Once again, if you are absent, you may turn in late assignments as long as they have a signature for whatever the absence that you have. But if you are not absent, they are not accepted. So, Shazam. And once again, part A's are always following the following week that we take it, so you can retake those. All right. Last night's home play, hold on to that. Tonight, it's only 3 pages. Pages 521 through 523 only. Pages 521 through 523 only. Just FYI, the first page is basically just writing out in words what the transformation is. You don't even have to graph or do any computation. Just explain, oh, it's going to go to the left, it's going to go to the right, and then blah, 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 blah. The following 2 pages is what we're going to do today on today's lesson. So stay focused, please. We don't need a Fourier model since we already know what the concept is for today. And, oh, by the way, quick commercial. Tomorrow, Thursday, informative meeting here in this room. If you're interested in drones, piloting drones, or any more in regards to that, be here tomorrow at lunch. We're going to go over some information, set some dates, and also get into more of the specifics about that. Yeah. Mr. What? Yes, but I don't know how that's going to work. But yeah, we're trying to come together and find out. All right. So our objective for today, I can write and graph radical functions. I can write and graph radical functions. Today we're going to finish this portion because tomorrow we're moving on again. So today we're moving on. I'm pretty sure you guys enjoyed the home play last night. Yeah. Yeah. Let's go. So our home plate for tonight has to do with radicals, and today we're going to finish that. But before we move on, definition for radical functions. Tell your neighbor the definition. We don't need a Fourier model. You already know it. Tell your neighbor, please. Radical functions are? All right, so I heard a variable under the square root. That is correct, or a variable under the radical. Yeah, so the rule should have that. Okay, so we don't need a Fourier model. We got that. And just to recap, when we first started with radicals, I actually went over the different functions that we covered so far, the transformations, what happens to each. And then I said, well, welcome to radical functions. Here it is. And then I introduced you to that. We did that. Well, today, check this out. We're going now with cubic root functions. Cubic root functions. So, on the big graph paper, get that in front of you, the big graph paper, on the top left. Top left, I want you to write this down, example 1, graph, and state the domain and range. F of x equals cube root of x. So I'm going to graph this in blue, but I'm going to make a table over here on the side. I got x and f of x. All right. So before I graph this and before I start adding values to this, yesterday, if you recall, with square root functions, we needed a number in there that we can take the square root. We needed an x value that can take the square roots. But now we have a cube root. So think about it. Don't say it out loud. Think it to yourself. Which values can we substitute in here for x that we can take the cube root without getting into decimals? Think about it first. Think about it. Bless you. All right, talk it over your neighbor. Which values do you think we can substitute in there to take the cube root? All right. Now I heard some of these numbers. I heard 0. I heard 1. I heard 8, but I still haven't heard any negatives.
-1.
That is correct. We start with -8. So if I substitute -8 in here, what does it look like? It looks like cube root of -8. What is cube root of -8? -2. Because what number times itself 3 times give us -8? -2. So if that's true for that, the next number would be, bless you, -1. If I substitute that in there, it should look like this, cube root of -1. So what number times itself 3 times gives me -1? -1. There you go. That is correct. And of course, the easy one is what? 0. Cube root of 0 is 0. And now that we're done with negatives, let's go to the positive. What would be my next one? Get it? My next one? Cube root of 1 is 1. And of course, the other one would be 8. Cube root of 8 is 2. All right, let's plot those points in blue. Here we go. -8, -2. -1, -1. 0, 0, 1, 1, 8, 2. No guessing. Be exact. Then that's not a guess. That's an exact quotation from this cube. Tell your neighbor, this does not change. That is correct. That does not change. These values, guys, when I ask you to graph me the parent function of a cube root, these don't change. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Those will always be the same. Students, cube root functions, students. Okay? That's what they look like. All right? Also, just to make sure we're clear on this, out of this whole function, tell your neighbor the vertex. What is the vertex in this function? That is correct. 0, 0, or this point that's in between the whole thing, also known as the vertex, or we also label it H, comma, K. HK will always be that point. Okay? So, yeah. All right. Go with domain. Domain. Solution set of x such that x. Now check this out. Look up to the screen. Look at this function. Notice that it has an arrow pointing to the left. That means it's going to continue going for all x values all the way to what? -infinity. And if it has arrow to the right, it's going to continue going with all x values to +infinity. Don't say out the answer, just think it through. If it includes all these x values, all the way to negative, all the way to positive, think about it, what would be my domain? What would be the domain? Oh, that's it. Tell your neighbor, what would be the domain, please? All right, let's see, Lene. Nice. Did everybody hear that? She said equal to all real numbers. That is correct. Why? Because it includes all the x values all the way to -infinity and all the way to +infinity. So, let's go to range. Range. We got f of x such that f of x. Now check this out. If this arrow, look up, for this function, it keeps going downward, that means it's going to include which values for y? All the way to -infinity. How about if this one continues going upward, it's going to include a what? +infinity. Therefore, tell your neighbor the range for this function. All real values. All real numbers. That is correct. Okay? And once again, what do I say? Yeah, that never changes. Very good. All right, any question with these? We good, right? All right. Switch graphs. Go to the graph that has 4 coordinate planes. 4 coordinate planes. 4? 4. All right. So you have four coordinate planes, one on each corner, yes? I want you to graph me f of x equals cube root of x on each one of those. Don't use a table. You already know the points. See how fast you can do that? And you use blue if you have blue. Okay? See, I'm going from left to right. The first one is -8, -2, then -1, -1. Okay. Blah, 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 blah. Blah, blah. On all 4 of them. All 4 of them. Hurry up, please. Yes. All right. So, now that you have that on all 4 of them, I'm going to start with the top left. Look at the coordinate plane on the top left. You already graphed that one, yes? All right. But now what I want you to graph on that one on the top left coordinate plane, I want you to graph the following. G of x, and I'm going to use red, minus or negative cube root of x. Now, before you say anything or start graphing, think about it. Remember yesterday we used Desmos? And it did something to the graph if it has a negative outside. Talk it over with your neighbor, see what it's going to do to that one now that it has a negative outside, and graph that one in red. I know. Be nice. All right, let's see. Good talk. Chloe. What does it do if it has a negative outside to this function? What? It reflects about which axis? That is correct. Did everybody hear that? Yes. Chloe in the house. She said it reflects about the x-axis. So this point reflects down here. This point reflects down here. This point reflects up here. This point reflects up here. Oh, yes. There you go. Go, Power Rangers. Dun, dun, dun. Hands of you are thinking about that? Yes? Okay. All right, let's go to the top right. Top right coordinate plane. I want you to go to the top right, and I want you to graph the following. And once again, we're graphing without tables, right? I want to make sure that we understand what we're looking at with negatives. G of x equals cube root of negative x. Don't say it out loud. Keep it to yourself. Let your neighbor struggle a little bit, and graph me that one. On the top right coordinate plane. All right. Tell your neighbor what it does to the original blue function now with that negative inside of the radical. All right. Who saw that it reflects about the y-axis? Yes? Yes? So this point, instead of reflecting this way, I reflect it this way. This way, or this point, it goes over here. Unite this point over here, and this point, wait a minute. Wait a minute. All right, and let's go to the bottom left. Bottom left coordinate plane. This one's going to be like the, what's that? We're going to use black on this one, or if you don't have black, use a pencil. Here we go. I want you to graph me g of x equals, check this out, negative cube root of negative x. Don't say it out loud if you already know it. Oh, yes. Oh, yes. Tell your neighbor what it does, please. All right, let's see. Chloe, pass someone. Who? Josh. What happens to the blue one according to this transformation? Ramon, what happens? It's the same thing. That is correct. If we reflect, check this out. If we reflect like this, but then like this, we end up with the same original function. So the reason I'm going over these with negatives because for the graphing portion tonight, you're going to have some negatives outside or inside the radical, and I just want to make sure that you know what it does. All right? All right. Let's move on. Let's go to the go to one of the medium-sized coordinate planes, please. Copy this one at the top left. Copy that at the top left. And it reads, graph, state the domain and range, and we got g of x equals 2 times cube root of x minus 3. All right, before we graph that, I want you to graph me the parent function first in blue, which is the one we already know how to graph, yes? Yeah. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. All right, now check this out. This is what I want you to do. Over here on the far left, I want you to write this table. X, f of x, and we're still doing this in blue. F of x. So I'm going to write the coordinates for all these points. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Okay. All right. So now that we have this, pay attention to this next part or you're going to get lost. Simple as that. Okay? Look up. By looking at the new function, we know the transformation that's going to happen to all these points. Look at it. Where are we going to move this blue one to? 3 steps to the right. That is correct. It's going to move the whole thing to the right. However, it has a multiplier outside. That means that's going to do what? Stretch it vertically. Okay. However, in order to see what it looks like, I'm going to make another table for the new function. I'm going to do that in red. But pay attention, please, because this is, like I said, if you don't get these first two there, you're probably going to get lost with the last. Ready? Here we go. Just pay attention. I'm going to write x, g of x. And the reason I'm writing it next to this, because it has a purpose. Pay attention to this. Here we go. We know this came from f of x cubed root of x. And we needed negative 8 in here because we can find the cube root of negative 8. Is that correct? All right. However, I can no longer use negative 8 in here because now we have x minus 3. So pay attention to this part. I would be able to find the cube root of this if this was what? Negative 8. Do you agree with that? So think about it. What value of x minus 3 will make this negative 8? Negative 5. That is correct. Let's see. Negative 5 minus 3 is what? Negative 8. So I end up with cube root of negative 8. What is cube root of negative 8? Negative 2. But what's outside? Times 2, which is negative 4. Copy that. Be nice. Okay. Negative 3. All right, here we go. So let me go over the process one more time to make sure we got it. We said the first value for the parent function was negative 8 for x. The question was, what value for x makes this negative 8? We said negative 5, so we wrote it here. Negative 5 and negative 3, that's negative 8. What is cube root of negative 8? Negative 2. But outside there's a 2 multiplying, so what is 2 times negative 2? Negative 4. All right, with that same process, let's go to the next number. What does the next number on the parent function have for x? Negative 1. Question, this needs to be negative 1. So what value for x will make this negative 1? Positive 2, that is correct. So let's see, if we substitute here a 2, I'm going to write it here so you guys can see it. So 2 minus 3, that's cube root of negative 1. What is cube root of negative 1? Negative 1. But then we need to multiply that times what? Times 2, so that is negative 2. How are we doing? Next, on the parent function, the next value should have been 0. So here, let me erase this really quick. Here, this needs to be 0. So what value of x makes this 0? 3. So 3 minus 3 is 0. Cube root of 0 is 0. 2 times 0 is 0. See if you can do the last two values according to the process that we just did. Copy that and go. All right, tell your neighbor the next x value that needs to be in there in order to get our next g of x. All right, I hear 4. That is correct. Because we need to have a positive 1 in here. So what value of x minus 3 gives us positive 1? 4. So we end up with cube root of 1. What is cube root of 1? 1 times 2? 2. And what's our last value? In order for it to be positive 8, what do we substitute in here? 11. That is correct. 11 minus 3, that's 8. Cube root of 8 is 2. 2 times 2 is 4. All right, let's plot that. We got negative 5, negative 4. 2, negative 2. 3, 0. 4, 2. 11, 4. All right, look at it. Question, didn't we say that it was going to move 3 steps to the right? Did it move 3 steps to the right? Yes. And what did the 2 do? It stretched it vertically. Do you guys see that? And if I was to ask you for the domain and range, what do you guys notice? Isn't it the same? All real numbers, so that doesn't change. Okay? Questions, comments on that process? All right? I'm going to move on to the next example, and if we have time, we'll come back to do one more of these just to get a little bit more practice, but I think we got these, yes? All right? So, on your other medium graph, copy this one, please. The 2 points given are this one. This one is at 1 and 7. And the other point is 2 and 9. 1, 7, 2, 9. All right? So you put these 2 points and you graph your function. There it is. But look at the instructions. It says, example 2, write the radical function given the graph. Did we do that practice last night? Yes. So what is the first thing we write? Our function. G of x equals a times, instead of square root, it's cube root. 1 over b, parentheses, x minus h, close parentheses, and outside we got plus k. All right. First obvious point will be our vertex, because our vertex is what? H and k. So by looking at it, what is our vertex? Our vertex is this point right here. That's our h, k. What are the coordinates for this point? 1, 7. 1, 7. And I substitute those in here. 1, 7. Okay. But now I need to figure out a and b. For a and b, I need another point. Mr. Q, why can't we use the same one? Because we already used it. Now we need a second point. What's my second point? This one. What are the coordinates for that one? 2, 9. So I'm going to write them here. 2, 9. And this is what we're going to use to find B and A. What do we write above according to your home play last night? B plus H, comma, or A plus K. All right, so I box this and make it into an equation. B plus H equals 2. However, what is the value for H here? 1. So that goes right there, and I bring down the B plus equals 2. That's all. Minus 1 minus 1. B equals 1. That goes right there. Now I need to solve for A. We box this second part, and I write A plus K equals to 9. But what is K now? K is 7. So A plus 7 equals 9, minus 7 minus 7. A equals 2, and that goes right there. And now we can write our function. Our function is g of x equals 2 times cube root of, what is 1 over 1? 1. Do we need to write it? No. So I just write x minus 1, and outside it has plus 7. And if you did it last night with the home plate, you're like, Mr. Q, this is tweezing. Right? All right. So, show me your fingers. I'll come figure out with number 1, graphing, and number 2 with writing. Okay, 5, 4, 5. Yeah, we just need practice. All right, let's see if you can do one of these by yourself. Ready? Copy these 2 points. Points given, this is 2 and this is 1. And this is 5 and 2. Let me help you out. Here you go. G of x equals. All right, let's see if you can finish it off by yourself. Copy and go. So you should have written your form. From there, identify the vertex, HK, which is 2, 1. Substitute in there. And from there, you identify the second point. What's my second point given? 5, 2. 5, 2. And then we write B plus H, comma, A plus K. And we identify what B is. We write B plus H equals 5. But instead of H, we substitute 2. B plus 2 equals 5 minus 2 minus 2. B equals 3. That goes right third. And for this part, we do A plus K equals 2. K is 1. A plus 1 equals 2 minus 1 minus 1. A equals 1. That goes right third. So my new function is g of x equals cube root of 1/3 x minus 2 plus 1. And have you got that? Yeah, we got this, yes? Hopefully for tonight, guys, make sure you work on those 3 pages only, 521 through 523. Enjoy. See you guys tomorrow. Bye. You too.